the course is called biofuel, so you might make yourself clear the definitions of what is fuel, what is biofuel, and what's the connection to, let's say, in general, energy. And the biofuel that we are handling here, so it's basically fuel made from biomass, so wood or woody biomass, lignocellulosic biomass, and also animal fats and triglycerides like different vegetable oils. So that's basically the raw material pool, and fuels made out from that are more or less biofuels. Biofuels are also renewable fuels and so on. There are quite many this green related terminology that is not maybe self-evident always, but just a reminder. Also these CO2 worries and global warming and so on. So there is fossil carbon dioxide, and then there is, let's say, biogenic or originating from biomass CO2 emissions. And this is not that important, but in any case, so if you have studied chemistry, so elements have, not all, but most have different isotopes, and for example, carbon has isotope 13 and 14, and some isotopes are radioactive, and usually the most stable ones are not. And this is actually the basis for carbon dating. If you try to figure out the age of some fossil remains or something like that, so you can use this same principle based on carbon 14 radioactivity. And this is actually used now when European Union has decided to, or is developing methods to figure out which fuels and how much they contain fossil-based materials and how much renewable-based materials. So the carbon coming from biomass, it's active in carbon 14, or it contains active carbon 14 isotopes, whereas the fossil-based carbon dioxide doesn't contain carbon 14, and therefore there is a, let's say, technical method or tool how to figure out how much of the CO2 is fossil-based or biogenic origin. Just otherwise, if we talk about how these different carbon isotopes react, so in chemical reactions, those behave completely in the same way. So there is no difference in their chemical behavior. But then few words about, this is like a background, or set, like the heading says, that setting the scene. So the big picture in this fuel and energy sector is, I have few slides about this, but the whole report or article is also, I think, in the supporting material if you want to study in detail all those different graphs and statistics. I wanted to just highlight few of the, let's say, eminent facts. And here you, for example, see the energy supply. So from which source the energy is from, and starting from 1970s, very close to our days. So one thing is that you'll see that the consumption is increasing, but then you'll also see the share of different, here is coal, oil and natural gas, and those are basically 80% of the energy supply and are those fossil-based ones. So at the moment, some roughly 20% of energy supply comes from somewhat renewable sources. And 10 years back, for example, the nuclear energy was not considered really renewable. But I think nowadays it's again back, it's green again. So there has been kind of change in the attitude towards nuclear energy. But in any case, so majority of the energy need is satisfied based on fossil fuels. And here you'll see the percentages of different fractions, but I will not go through now those. Then if you take a look at the oil, so oil, which is like about 1/3 of the energy supply, so where it's going. So I would say, to me, the key observation is that like 2/3 goes to transporting of goods and also mobility of persons and stuff. So if you add all these aviation, road transport, rail transport, and also navigation, meaning this ship transport, so that adds up to some 2/3 of the whole use of oil. And there, the thing is that there also these, let's say, liquid fuels and liquid biofuels have a very high potential in replacing these. Because what I have understood, so like in passenger cars nowadays, we have these electric vehicles that run with electricity and battery stored energy. But if we go to aviation, for example, so there aren't really batteries that could work well enough for the airplanes to fly long distances. The same goes for transporting of goods when it goes to the heavy vehicles, trucks and things like that. So the liquid diesel is still the fuel that is the most difficult there to replace. And roughly also in the shipping industry, so still these fossil-based, or at least more or less liquid-based fuels are there, quite difficult to replace. But the potential here is then for the different biofuels that the course is about. So it could have a quite high impact, thinking about airplanes, trucks, and heavy machinery, excavators and such kind of things, and also to some extent in ships. Also, or in elemental chemistry level, so if you think that the oil itself, crude oil or petroleum, it's basically source for carbon, and also it contains, because it's a hydrocarbon mixture, so it contains hydrogen, and as unwanted impurities there is quite some amount of sulfur and many other minor ingredients, some metal salts and such kind of things. But the main thing is that where the energy comes from, basically, so it's combustion of the carbon and hydrogen components in that oil, and those same elements are also found in biomass. So there is kind of on an atomic level, let's say, similarity. What is related like products? So this is not any exhaustive complete list, but few examples. So if you think about the mobility and transport sector, so cars run with E95, E98 petrol or gas, diesel, oil, and aeroplanes utilize jet fuel or kerosene, or kerosene is refined into jet fuel. Also paraffins and are used for heating, for example, heavy fuel oils. Then there are these light fractions that are used in the, let's say, domestic stoves and heating purposes. And well, these lubricants are maybe processed a bit further, so these could also be the petrochemical products, but it could be positioned also on the left side in this graph. But many of these components are already in oil, like petrol, diesel, kerosene, paraffins, and these liquefied light gases. So they are already in the oil, and those are just separated by distillation in the oil refinery. And then the second step when it comes not just oil separation, but the refinery, so then it's later on can be refined or chemically converted into, let's say, different types of products. But we'll come back to those slightly later. Then very often the oil refinery and petrochemical industry are physically located nearby each other. So some of the fractions coming from oil refinery are sent to petrochemical industry. The main things or products that come out there are polyolefins or different, let's say, polyethylene, polypropylene plastics, different solvents, and also, well, ethylene dichloride for making of PVC and such. This list would be really long. I just didn't put there many examples, but these are like products from oil refinery that are processed further to valuable chemicals, valuable products that this, let's say, our modern society needs for this today's style of living. Sulfuric acid is not organic molecule or hydrocarbon, but it's also like it's a impurity that is removed from oil, and there is plenty of it, and it can be converted to sulfuric acid, which is, I don't know the exact statistics, but on the top 10 most produced chemicals in the world. It's used in various applications. So some background, some 20 years ago was the last, at least, hype of renewables, or it started the latest hype. And well, these are all things that are more or less clear, certainly to you. So the concern behind there are different types of adverse or negative effects to nature, to sea, and also air, and us humans as well. So global warming and different pollutants, carbon dioxide emissions that promote the greenhouse gas effect, and so on and so on. Another thing what is closely related to fossil fuels and oil is different political issues and problems, instability, etc. So the importance of oil and fossil fuels has been and still is so huge that if there is certain like instability or uncertainty, so it has a huge influence in our economy. And the latest examples might be this Ukraine war, and also what is happening in this Middle East area at the moment. So even speculations of problems in oil supply increase the oil prices and so on. And this is something that we want to avoid. And the renewables offer a solution or possibility. So that's on the political side. Also, there are some trends like sustainable development, which is highly green or renewable energy favorable. The circular economy thinking is also emerging. And that basically in this energy sector means that we don't want to rely on virgin fossil fuel or oil-based materials, but we would like to use recycled or let's say waste fractions and such kind of things instead. And one huge driver, most of you or all of you probably are located in European Union, so EU is or at least wants to be this global leader in this type of green and renewable sector. So there comes lots of new legislation and new policies that favor this transition from fossil to renewables. EU is aiming, for example, to climate neutrality by 2050 and so on. But this type of background. Future, these are things that are linked closely to the different courses offered by the program. So basically, we are still living more or less on the left-hand side, where the dominating energy supply is the fossil-based gas, natural gas, coal, and oil. But these newcomers, these renewable energy, biofuels, and so on, they are like, let's say, their share is increasing. And this particular course is dealing with biofuels, not much about that in this case. The other second one is waste to fuels. So that is course that is dealing with how to replace, let's say, these virgin fossil materials with different type of waste fractions. And that's this, it's called co-processing. And the same oil refinery that is basically running on fossil petroleum or these fossil fuels. So some of that feed can be replaced by waste materials or with biofuels, biomass, and that is called this co-processing. And it's the way that, or let's say that it's the trend to go at the moment. This power to X is something that is not mentioned at all in that course book that I share with you. That's the new thing that has emerged during last 20 years or so. So it's basically a method how to store renewable energy coming from solar panels, from wind turbines, and so on. So you can use that energy to break water molecules, and hydrogen can be stored as such, or it can be used together with captured carbon dioxide to make products like hydrocarbons. These are called then synthetic fuels, but those are the very similar products that the oil refinery offers already in their fossil-based processes. But these, of course, are considered renewable as the source the energy input comes from the renewable energy. Also here, high up is the, let's say, revival of nuclear energy. So it's again very popular in Europe. And new thing is at least in Finland, the discussion of this small scale nuclear reactors. So not maybe making these huge power plants anymore, but making more of the small units for heating purposes, not making electricity, but such kind of applications. Biofuels. So this is one article that is pre-reading material. This is just some of the headings from that. Of course, it's more or less clear that biofuels can be solid, liquid, or gaseous. And of most importance and most what we cover during this particular course are the liquid biofuels. So different types of bioethanols, different renewable diesels, FAME and HVOs and such kind of things. Also pyrolysis oil, and not so much these drop-in fuels are more in that power to X course. But in any case, I don't know if you have encountered this term drop-in fuels very often, but it's basically the situation with all renewable or biofuels that they have to fit the current engines and the current distribution networks and applications in order to be viable. So this is basically the case that you cannot like use a renewable fuel if the engine is not compatible or if the after treatment unit is not compatible. So therefore it's kind of the good old oil refinery and fossil fuel industry that has set the standards and quality requirements that the new fuels have to live with. So basically that's the drop-in fuel. You can make whatever nice bio things, but if your car doesn't work with it, so then it's not that useful. Still background a bit. The oil refining, that is still the dominating era. So it started after more or less Second World War or in the 1950s. So it's very, very old sector or industrial sector, but it's so huge and important that, well, it's difficult to replace. And I think even with all these bio and renewable things, so it can be very challenging to replace the volumes and the amount of energy chemicals and products that are currently made from fossil-based raw materials. But interestingly, when I started to do research in these renewable or green chemistry areas, so I noticed that at that time, I'm talking about beginning of 2000 or 1990s, end of 1990s. No, at that time the oil industry was the really hype, and nobody thought about using bio-based materials on anything. So when the bio-based or industry became again hype sometimes in the beginning of 2000s, so many of these, let's say, research and processes and reactions were already invented like before the oil refining era. They were just not they couldn't compete with the cheap oil and the amounts that the or the energy needs that were at that time. But many of these, like Fischer-Tropsch and some other processes, so those originally were invented in the beginning of 1900s. So that's kind of interesting that we are now in one way returning back what used to be 100 years ago. Of course, it's in totally different technical level, but in any case, this I already mentioned in many instances, but that's something that to keep in mind. So the problem of replacing these hydrocarbon fuels with anything, even renewable like electricity or something, so it's problematic in these airplanes and trucks, heavy machinery. Otherwise, renewable energy can be more easily applied. I have been now talking quite a lot. Are you still there? Any questions maybe, or?
I have a question about the publication that you showed before. I was wondering if it can be uploaded in the material for the course.
Yes, I have uploaded it there, but I think it's in the section 2 or section B. So
okay, sorry.
You'll get access to it like very soon. Okay. Yeah, so few words about this, or let's say highlights from the fuels. So that I said that the bio-based fuels have to comply with the current fuels. So they have to comply with engines and after treatment systems and so on, and they have to comply with the distribution networks and so on. So just we will not take a look at these very much during the course, but there is a kind of lots of standardization and legislation behind of these, that what is allowed and what is not allowed in the different fuels. Some of them are like pollutants, like let's say sulfur or heavy metals or some other problematic things, and some are just like, let's say, incompetent with the after treatment, like catalyst or such technologies. And I don't remember what was the next. Yeah, here very often, at least already 20 years ago when I was dealing with these biofuels, so the problem with commercialization is the lack of standards. So there EU has taken steps forward to develop these biofuel standards, but that's maybe, or it's very important if you want to commercialize and take these biofuels into everyday use. So although it's maybe not that popular to study or develop standards, so it has important role. These are self-evident probably to everybody, but I mentioned this road transport. So still the majority, at least in Europe, so runs with diesel and gasoline, and this co-processing or adding of renewable components, it's a way to tackle the greenhouse gas emissions and global warming. So the current diesel and gasoline that you fuel your car with, so it contains certain amount of renewable, like biocomponents. So those are mixed in that. The electrical vehicles are coming popular. However, those are not solutions to all road transport, already mentioned many times. And personally, I have even been driving the natural gas powered vehicle with this compressed natural gas. And I think that could be quite reasonable alternative if you use, instead of natural gas, the biogas. But for some reason, European car manufacturers are not anymore putting effort to this gas vehicles, at least not passenger cars, because all the interest is put in these electrical vehicles. And personally, coming from Finland, we have quite cold climate. So at least here we have quite huge problems with let's say the range and in any case how the electrical cars are working in cold climates. So when the temperature is -25 or -30, so the batteries are not very well giving power anymore. Here is same info about this fuels on different sector. So now fossil fuels tends to dominate. Diesel and petrol are the largest, and biofuels, at least according to these statistics, cover less than 10% of the use today. We come back to this later in assignments and so on, but just to keep in mind that the gasoline itself, what you put in the gasoline-driven vehicles, so E95 or 95 octane or 98 octane gasoline, so it is not one single component, but it's a mixture of several hydrocarbons and also some additives that have been tailored in the oil refinery blending station. So when you talk about, for example, bioethanol, so that's one single molecule and one single chemical. But when you talk about gasoline or diesel, so it's mixture of hundreds of different chemicals. The same said already about diesel, but the aviation also uses hydrocarbons as fuels, and I'm not expert on that. I just took some examples that there are understandably heavily standardized fuels that are used in the aeroplanes, and but these again are, there were some information last week in the news about Neste, Finnish oil refinery or company that produces this renewable jet fuel, but the market is still very small due to higher prices and so on. I think it was very marginal, less than 1 promille of what is used renewable fuels in aviation today. But like I said, I'm not expert in this, but their airplanes run on fossil fuels, one can say that for sure. And another area that runs on fossil fuels is the shipping or ships that transport more or less goods or stuff all around the world. And they use the most heavy and most polluting oil fractions usually as fuels, because those are the cheapest ones. So the heavy fuel oil, or sometimes I'm not sure if this is called, but they also use so-called bunker oil, which is basically solid material at room temperature. So in order to pump it into the ship, so it has to be heated to quite high temperature to become liquid. But I have also worked quite a lot with this Wärtsilä, which is Finnish diesel engine manufacturer, and they are focusing on these renewable fuels in this shipping industry. And for example, this liquefied LNG is becoming quite popular alternative. Also, I have heard that methanol could be retrofitted to current diesel engines. There are some corrosion problems, but not with the engine, but let's say pipelines and other things, that methanol is much more corrosive than the traditional hydrocarbons. Also, hydrogen is used in some ships, and ammonia could be also a potential fuel. All of these in principle could be made from, well, liquefied natural gas, of course, is not as such from biomass, but hydrogen, ammonia, and methanol could be made. So I'll see that I'm starting to repeat myself quite a lot, but the fuels as such, so you can group or categorize them in various ways: solid, liquid, gases, and based on the raw material, renewable or fossil based, and then also natural or synthetic. And of course, the possibilities in the synthetic fuels is much higher in number than the natural fuels that could be used as such. But there is this lower part of the picture refers to this oil or fuel storage tanks, and that refers to the synthetic part. So keep in mind that whenever dealing with the fuels, so we deal with bulk chemicals, very large volumes, talk about thousands of tons or liters usually. So it's classical example of bulk chemical industry. Here is nothing new. It was just an example that you can find. Actually, I struggled a little bit to find a natural liquid fuel, but then I remembered that some diesel engines can run on pure vegetable oils after certain modifications, but otherwise here is nothing that special. I already touched this fuel composition a bit, but if you think about the fuel that you are using in your car or some application, so the most common things today is fossil-based fuels, which are complex mixtures of different components, hydrocarbons, where the energy comes from, additives that improve certain properties of that fuel, the combustibility, provide lubrication to pistons or stability or increase the storage time, etc., etc. Then there are some chemically single component fuels which are also available. So examples being like ethanol, methanol. These are just single chemicals or molecules, and the fuel is made basically purely out of those. And these could be from fossil or bio-based origin. Then more typically, the fuels that we used are blends of fossil and bio components, like petrol and diesel. And then in addition to this, there can be pure bio-based fuel mixtures. So there is, for example, the HVO, hydrotreated vegetable oils. So it's compatible to diesel, but it's purely made from bio-based or renewable materials. But it's not one single compound, it's a mixture of several hydrocarbons. This table I have shown quite some years ago, so it still exists. I checked the links, but the main point here is that if you think about the energy density what the fuels contain, so here all sorts of batteries that are very popular in passenger cars today, so those have the worst energy density in terms of energy per mass and in terms of energy per volume. And the traditional diesel, gasoline and such, they have very high energy density, which of course gives you high range for traveling or basically low weight for the fuel and so on. So there are properties that are difficult to solve with let's say batteries and some other alternatives. So this is of course the diesel, gasoline, kerosene compatibles could be made from renewable sources, and this energy density is their, let's say, strong plus side in their properties. So if they have to compete with battery technology, so it's definitely the high energy density that is on their side. So here are properties of fuels that if you think about the benefits, disadvantages, what is optimal for certain applications. So it's not only about the one parameter that defines which fuel or solution is selected, but there are like many properties like how it can be transported, which is it easy or difficult to store, can it be stored, what about safety, like flammability, is it explosive, and so on. The energy density higher, the usually better. This is often used also does the infra exist for the distribution? If you think about hydrogen, so very few cities have pumping stations for hydrogen, so therefore nobody buys a hydrogen-driven vehicle for their everyday use. So there is this problem with to consider. Last but not least in this list is the compatibility. Is it compatible or is it standardized? Can it be used in a flexible way in current vehicle, for example? And in this course, we are mostly interested in this mobility or transportation related applications, but of course the all liquid or all biofuels can be used for heating, for producing energy, for producing power and such. So it's not any limitation, but there are cheaper alternatives available. So the best value addition is in this transportation sector. And well, this is just a picture to remind you that when we talk about biomass to fuels, so we'll see often these greenish pictures of nature and trees and clean environment, but in order for it to be like realistic. So it goes through this bulk chemical industry, which is extremely large scale wise. So it's not done in small scale, the production. Biofuels life cycle emissions. So this applies, of course, the same like well to wheel life cycle estimations to fossil fuels as well. But there, in the 20 years ago, in particular, this bioethanol production. So there was consideration that if this beginning part of the life cycle takes more fossil energy than the actual product in the end contains. So of course, in order to make any sense, so the end product has to have some net energy in it in order to make it somehow profitable or reasonable. Here are some examples how to convert biomass to fuels. And there are basically two different alternatives. So one is the biochemical conversion route. So there you'll convert sugars or sugar-containing material via microbes. You ferment it to ethanol or other chemicals, or you can use the other methods also to make the similar products. Lignocellulosic biomass is one route. It's different from the sugar because it needs different type of processing and so on. Here is also mentioned mixed biomass, waste residues and such. And fourth one is the different oils, fats and lipids, which is chemically one group of components. And there one ends up with different type of product as well. So this is the biochemical conversion. You'll end up, for example, with ethanol, hydrogen, biogas, which is more or less methane and carbon dioxide, and then biodiesel. The second possibility is thermochemical conversion, and on this course, the gasification, pyrolysis, and liquefaction are maybe more relevant. The torrefaction and combustion are in this graph more for heat and electricity production, so that's not what we are aiming on this course. So here are some aspects of this biomass conversion. And first of all, on the left-hand side, so we have these different raw material pools, like lignocellulosic material mentioned already multiple times. So it comes from biomass. So everything green in nature, it's composed of lignocellulosic material. So all vegetation, trees, grass, different plants are potential raw material. Of course, you prefer to use waste fractions or non-edible crops or let's say parts of the plant for making fuels and so on. We'll come back to that in the coming lectures. But there are also these problems related to the biofuel production, and the availability is mentioned here. So that is closely related to the huge use of crude oil at the moment. We are using so much of petroleum or crude oil that it's more or less impossible to replace with one single alternative. So we need lots of different solutions to cover the huge consumption of oil that we are where we live at the moment. Also, the competition with food production. So food is preferred over the fuel, and there we come to this first generation, second, third generation biofuel concepts that we come back later. And just to point out that very often the biomass-based fuels are expensiver than the fossil fuel-based materials. Not necessarily always, but very often. And the reason being that the oil industry is so mature, it's so fine-tuned and well-developed that it's very difficult to compete with it. It's very efficient in terms of yields and conversion rates and such. Another thing, of course, in this crude oil, is that the raw material price is changing depending on the stock market or situation. So when it's very high, the renewables are popular, but when it comes back to the normal, rather low level, so the renewables are not anymore that tempting. Okay. So these are the final slides that I have today, and I was thinking that we could try to discuss this a bit, but let's see how it. At least I listed some introductory things or stuff that you might consider, maybe yourself or later on. But like the current share of renewables versus the dominant technologies like the fossil fuels. So it's not developing very well, like I showed you in that first slide. So energy consumption is basically increasing, although the share of renewables is increasing, but yet fossil fuels cover like more or less 80% of the energy supply. And if that increasing trend continues, so then, well, it should perhaps decrease if we want to save these or solve the current problems with the CO2 emissions and global warming and such. Then for the coming lectures and parts of this course, so keep in mind that what are potential applications for these different types of biofuels. So what fossil alternatives those could replace, because in use of biofuels it doesn't make sense in all applications. So this is not, biofuels are not the one single solution for all the problems, but it's, let's say, one tiny piece of of this whole renewable sector. So many other solutions are needed, and those have to work together to solve the problems. And then I didn't talk much about the problems or key problems related to use of fossil fuels. But one might try to reflect, like, let's say, the problems and of fossil-based materials versus what solutions biofuels offer or mitigate. And biofuels are not solutions to all the things.